Can everyone hear me? Hello?
Yes, we can hear you loud and clear.
Yes,
Oh,
hello.
okay. Thank you. Let's keep waiting for everyone, for at least some people to join, because we are 1 minute so we can start our meeting. Okay. Thank
Yes,
you.
thank you, Relax. I think we can start now. Wow,
Okay.
I believe others will be joining us along the way. Yeah.
Okay. Thank you very much. Thank you very much for this. So we can officially start now, right?
Yes, please.
Okay.
I
Let me
think
put
you
my
should put
slideshow so everybody.
your slide in.
Yeah.
Yeah, perfect.
Okay. Hello, everybody. At my time here in East Africa, it's like 19 p.m. at night, and probably Warri is 17. I would like to welcome everybody to this session. Before starting anything, I'll start by introducing myself. My name is Hilat Duma Gunda, and I'll be the host of today's session, which will be presenting about the process of engineering for sustainable upstreams and midstream operation, dynamic and relevance. So without wasting time, I would like to start this webinar officially. It's 1901, so I would like to start it officially, and I would like to take this time to welcome everybody in this pleasant webinar. So our webinar today will have, I'm pretty sure everybody can see my screen. This will be the timetable of today's event, which will be carried out. Won't be going through one by one, but I would like to take this time before beginning. We would like to see how this topic is relevant. Why do we do this topic today? Why did this session be organized? Without going further ado, this session was prepared by SPE Warri session. It's collaboration with SPE Tanzania section. As you can see, my name is Hilat and I'm from SPE Tanzania section. And here in the timetable, we could see moderators from both sides of the sessions. And the topic we're going to start today, I've already mentioned it, and it's all about seeing the challenges and opportunities we are facing across the industry today as we push efficiency and sustainability. Technology advancement and process engineering continues to play a central role in the shaping the future's upstream and midstream operation. We hope today's session will be broadened with understanding, spark new ideas, encouragement to young professions, to all the profession all over across the regions. Before beginning, I would like to put a few housekeeping, which will be given to us by David Mrema. Is David Mrema available from SPE Tanzania section?
Yes, I'm here.
Yes, thank you very much, Daudi. Thank you very much for being here. And I would like you to pass us through some housekeeping, safety brief to the listeners today. Welcome, Daudi.
Thank you, Hilat. Good evening, everyone. As introduced, my name is Daudi Mrema, a YP from SPE Tanzania section, and I'm glad to be here with you all for this wonderful topic that we're going to discuss. So we're gonna go through safety briefing, just a few things to note down as we attend this wonderful webinar. The first thing, uh, be sure to mute your microphone when you are not speaking. Only when you are allowed to speak, that's when you can unmute your mic and speak. So be sure to mute your mic when you're not speaking, unless you've been allowed by the moderator. Another thing is when you have a question or you have a comment or anything to say, be sure to raise up your hand uh, so that the moderator can see it and she can allow you to speak. Also, if you want to type anything, if you are not comfortable speaking, or if you're in an area that you cannot really speak and you want to ask a question or you want to put a comment, you can use the chat button that's in this webinar. You can use the chat button. You can put your comments. You can put your questions, and the moderator or the host is going to see it. Also ensure that okay, someone's mic is on. Okay, ensure that you can still hear the fire alarm wherever you are with your headsets. So if you're in an office or if you are in the area that could be that could be a risk of fire, make sure that you can hear the fire alarms and be sure to allocate all emergency exits and follow all the safety procedures wherever you are. Also, be at alert and be aware of your environment. Wherever you are, just be aware of your environment. If you are in the office, if you are at home, if you are driving, you're on the road, just be aware of your environment. Take care and follow all the safety rules. Also, if you are sitting on a chair, make sure that you maintain a good sitting posture. Don't lean too forward, don't lean too backwards, but maintain a 45 degrees angle whilst you're sitting. It's going to help you with your body, especially the back. So maintain a good sitting posture. But in the end, always stay safe and enjoy this wonderful webinar. Thank you so much, Hilad. I think that's all for the safety briefing.
Oh, thank you very much, Daudi. That was a very good, safe brief. And I hope everybody noted what was going on. And I hope everybody can see my screen. So if you didn't hear it properly, I hope you could see my screen and get note to everything that he was saying. Without further ado, we'll continue with this presentation. And this time around, I would like to open Dr. Sylvia Okotie. This is a senior member of SPE Warri section for the opening remarks. Dr. Sylvester, can you hear me?
Yes, thank you, Ilat. Once again, good evening, everyone on the call. You are welcome to this YP's technical section. It's always a period where we gain meaningful knowledge from our industry experts, most especially in this critical era of our operations in the oil and gas industry. So you are once again welcome to this section, and I believe every one of us here, we came here with the mindset to gain one or two information in this area, especially the dynamics and the relevance of process engineering for sustainable upstream and midstream operations. Luckily, we have a senior engineer here in the oil and gas industry in the area of the process engineering with vast experience with Arade Holdings. So I just want us to keep our mind open because when we look at the area of process engineering, it's one of the critical and vital area for a sustainable upstream and midstream operations by way of optimization, efficiency by way of reducing environmental impacts for operation and ensuring safety is adhered to. So it is one key area that we need to really look at to strike a balance between our economic goals with ecology and that of our social demand to meet this sustainability we are talking about. So I believe the speaker will have to take us through the dynamics that will have to do with a shift in the drivers, technology, how we'll be able to integrate our technology into this for a sustainable operation, looking at the complex optimization process that are involved, continuous improvement, and the dynamic capability that will delve into the relevance in the area of economic viability, environmental responsibility, the without missing out of the safety and the risk management, then having to do with the rigorous regulatory compliance and the innovation and the future of this aspect. So I just want to encourage every one of us to be open and keep your questions open. Ask relevant questions when needed, and I believe at the end of it, all will all leave here excited and remain blessed. So just a way of welcoming us once again. Thank you, everyone on the call, and ensure you stay back. Thank you.
Thank you so much, Dr. Sylvester. This was good. I hope y'all listened to this and it made you very feeling at home in this webinar. You were given the chance to ask everything you need to know. So I hope this will be a very fruitful time for everybody. So without further ado, let's keep going with this webinar. Before inviting and letting our guest speaker speak, I would like to a little bit introduce who are we talking to, who are we supposed to listen to, who are we here all for. Meet our speaker, Engineer Bero Adipan. He is a senior process engineer, Ardell Holdings, in Ardell Holdings. Now, who is Engineer Bero? Engineer Bero is the current registered process engineer specializing in the design, optimizing, and safe operation of oil and gas petrochemical facilities. He works across greenfields, concept to startups, and brownfield debottlenecking with strength in process simulations, high-sis assessment, hazard lock, flare and relief systems, produce water, treatment, and energy efficiency. Adibitan began his career in operations, supported the commissions of a 10,000 barrels per day refinery at Aradel Refineries, and now delivers in engineering and projects. He holds a bachelor in engineering in chemical or petrochemical engineering from River State University of Science and Technology, advanced studies in process engineering from University of Lagos, and postgraduate business degree from Edinburgh Business School, Heriot-Watt University. Passionate about data integration, digital workflow, he builds tools that speed decisions and supports the commission's oversight from design review through commissions. His lecture, Process Engineering for Sustainable Upstream and Midstream Operation, Dynamic and Relevance, distills practical methods to reduce risk without slowing delivers. Now, this was just a small biography of our guest speaker, and now I would like to welcome Engineer Barrow to keep going with the presentation. Engineer Barrow, can you hear me?
Yes, I can hear you. Thank you, Elias and Dr. Sylvester, Paul Alabi. I think Paul Alabi and I have been having a conversation with respect to this technical lecture. I mean, it's something that I've done over the years, attending lectures here in Lagos, Nigeria. And it's, pretty much interesting that over the years, these are some of the inspirations some of us have gotten by attending some of these technical lectures. And it's pretty much interesting that at this point I'll be giving back to the, to the industry. And I hope that at the end of it all, I'm able to inspire new minds and young engineers that are probably coming into the industry, and those that are in industry already, to see the significance of what process engineering is. And if you are taking up the role of that of a process engineer, then you see the benefits at large. Without ado, let me just share my screen so that we can get into the lecture. Please confirm I have the right to share my screen.
Yes, sir, you do.
Oh, okay. All right.
Right.
Okay, thank you. Sorry, just a moment. Oh, kindly confirm you can see my screen.
Sir, we can see your screen.
Okay, all right, beautiful.
Yeah.
All right, so thanks again for this invite. So we'll be looking into process engineering for sustainable upstream and midstream operation, the dynamics and relevance generally. So what we will be learning, from this technical lecture, they are in 5 blocks, saturated with a couple of things that will be taken away from this lecture. So we're going to be looking at what process engineering definition is, understanding the dynamics of this engineering as it relates to process. Then you'll be seeing a project life cycle, because as a discipline engineer, you also be participating in a lot of oil and gas activity, works. You could either be a project engineer on a specific project, or either as a discipline engineer working with other team members and all of that. Alongside all of these, which are very critical, essential things that you will be doing, is that you actually can do nothing without, having some engineering tools, which are very critical to, building and all of that you have to do when it comes to process design, and all of that you need to achieve when it comes to, project management. Then you're also going to be seeing the relevance of process engineering in the industry. Now, please confirm you can see this very screen.
Yes, sir, we can see the screen. You can continue. You can continue.
Okay. So now, don't be moved by the idea of everybody pointing the fingers and trying to blame the guy. This is actually not the way we work in the industry. We work as right, and this coming together to do all of that and all that. But then, what you see here depicts what you are likely to encounter if, as a process engineer, you do not understand your importance in the industry. At many forums and different places, I've had engagement with a couple of engineers, young ones, even colleagues. I usually see that whether you like it or not, the process engineer is a dictate of every single thing, every single thing you see on the surface. And what do I mean by surface? I'm talking about practically everything you can see in terms of whether it's the civil engineering works, the instrument that will be coming at a time, the equipment, the mechanical works, and all of that. The process engineer is the dictate of every single thing that you see on the surface facility. Once you get it wrong, there's 50% chance that everything could go wrong and you have to go back to the drawing board, making sure that everything is properly done. You can't be a process engineer without understanding some basic fundamentals, because this is what, dictates every other single element that comes on stream. Typically, let's say you want to start a facility, you want to build a facility. One of the dynamics that's often dictates how we see the direction of what we want to do is the weather condition and the terrain you want to build, whatever you want to build. And the most interesting thing is this, because one of the variables of process dynamics is, centered around three elements that we look at when it comes to process variables, and that's bordering on temperature, pressure, and volume, which has to do with the flow rate. Now, speaking to what I said earlier, when it comes to looking at the terrain and the region you're going to be operating, and you want to design a plant as its way, one thing that is very critical to this element is the temperature of the region, because you need to understand the region and understand probably the lowest temperature they could be, or probably the highest temperature, because these are things that are very fundamental to how you build your system. Take, for example, if you have to build a system in somewhere like, let's say Scotland. Process check. I have a voice in the background. Okay. All right. So you are building a system somewhere around, take, for example, Scotland, somewhere in Scotland, that where you can almost have the region cold every time, maybe at -2 degrees Celsius. You can't compare that to a region like us here in Africa. And so you're trying to build a system, and what's, is critical to that process that you're looking at is the temperature. For example, you are building a flow line, and as part of the characteristics of the crude that you're building is that it could have what you call a wax content. And we all know what wax is, that at a very low temperature, you begin to see the slimy formation that could, at the end of the day, create some kind of a formation and constraint along your pipe walls. Now, what do you begin to look at is this. If you want to build in Nigeria, maybe Africa, some of the things you must look at, which is very fundamental, is the temperature, and knowing that, look, in this region, even if you're going to have a wax condition, it's probably going to be that at the end of the day, you only be able to mitigate it with maybe a chemical intervention, as case may be. But then when you are in Scotland, maybe at -2 degrees centigrade, you probably will be looking at it as, okay, as part of what you'll be doing is probably a combination of what's chemical and some heat transfer to the pipe wall to keep the fluid, to keep it flowing. So you need to understand what you do as a process engineer, because there are certain things, very critical element that you'll be looking at when you begin to design a process, getting information and all of that, as you manage the process, because it is on the basis of what you are doing in terms of the design that each other discipline engineer will be latching. All of that they will be doing, whether the electrical person, in terms of instrumentation, okay, what kind of control am I putting in this place? Oh, the process engineer says it's going to be this volume, this rate, and all of that. So I have to put this system that can manage this rate. You see the operation and maintenance guys also talking about, oh, I've not been able to operate my facility because of the poor design of the facility. Everybody looks at the engineer. Who is the person? Process engineer. You're also looking at the piping engineer. Oh, he said it was going to be 10,000 barrels, but what I'm getting is about 12,000 barrels, and my pipe can't actually manage what I see here. Looking at the flow rate and the flow that going, and all of that. You look at the civil engineer. Okay, you have design, say, a separator which is going to be for 10,000 barrels and all of that. If you poorly manage the design process, then the foundation that the equipment is also going to be sitting on is probably going to be done wrong because of the wrong information you have provided to this element. Likewise, the process safety engineer that you will be likely be working with and all of that. So you must understand your importance when it comes to process design as a process engineer in this industry. So what is process engineer? We could look at it in different fashion. Like I like to joke with friends, say as it is. We can look at it in a very artistic manner. I mean, you can talk about it. It's actually where, pressure, temperature pipes, and, stars, valves, as notes. The sketch invisible forces, tames chaos into flow, because you deal with a lot when it comes to flow essentially. There's so much that happens when you look at the dynamics of flow and all of that. I want to balance safety as well, and try to be as profitable as you can, and also making sure that the environment is also not fouled, and you're doing the best you can do to keep our environment safe. Can also look at it from the basic way. If you're talking to a new entrant, we all did physics and chemistry as it is. When you look at it, we say process engineering is where physics becomes architecture and hydrocarbons, learn to dance to the tune of chemistry. The pipes that you're looking at are physics in nature, you understand, mechanical, and they help to guide the chemistry of flow that happens on the pipe. Now, looking at it essentially as process engineer, looking at it from this terminology and full definition as a process engineer, that in this oil and gas industry is a discipline, right? Where discipline engineer controls the physical elements, transform the chemical reaction, and that converts stuff like hydrocarbon streams into reliable products and optimizing safety, efficiency, and environmental stewardship. As a process engineer, there are three cores that we like to speak to, which are the guiding principle to all of that you look at, because you are building a process. And one thing that you must take cognizance of are these three cores, these three elements that are very critical to, building a project from the scratch, from the moment you get a project charter from the management. When it comes to the executive level, comes to the practitioner themselves, all the way to the shop floor. So you have those elements. The safety is very critical. When it is not safe to operate, then it is not what the investment. It makes no sense. Sustainability. Are you building for tomorrow? Is it scalable? And how is it, how does it interact with the environment, all of that? You need to look at a couple of things, how you handle your water, your flaring systems, quite a number of things. You can build a facility and, for example, let's take for what it is, and I'm sure it's something that a lot of us are familiar in our industry. One of the things that is frowned at is the flaring of our gas. Of course, you flare gas, but there is also a commercial side to it, which is you are flaring, and this is something you can actually commercialize. And you need to see, the whole process engineering, perspective on how to optimize the system, safely build, make it sustainable, and making sure that it is profitable. So your role is knowing how to integrate this series of elements that we're talking about, such that you are able to, design and make it fit for purpose. Those safety elements are considered, make them robust, scalable, and so that they are scalable. So you have a facility, you have to think out of the box, knowing that you don't build a system that is not scalable, because you just can never then tell investment will grow within a short space of time, and the investors are looking at putting more money in your asset. And the next thing we'll be asking is that they are calling the guys into the room, particularly the process engineer, to state what the constraints are, if it is possible to expand and all of that. So you must build for the future, which is something that is very critical. Now, why do I have this screen to share with us? I'm sorry, a couple of us may have come across what I have on my screen, which is, it is actually a surface facility designed for, it's actually a very integrated facility. This is some of the past design I've done, and these are actually simulations that we built, and that speaks to what our live plant is. So these are the different streams of wells. You have the flow lines, you have the valves, you have the manifold, you have So with the way this integration is, of course, I didn't capture it here. The NAC separator is to help stabilize the condensate, which is the gas well, which is the non-associated gas coming into the facility, stabilizes it at about, say, 950 psi. You have a liquid stabilized and going down into another integrated facility is the flow station. This is the flow station. And you also have different streams of well that are AG wells, which is those ones that I call associated gases, associated gas wells. And typically you have the API around API 35, 36, 42, all the way down, to the heavy, but, so this is the place with the gas and the water, the streams of fluid, and you have the overhead going into the gas plant compression system. This is the compression system where the gas goes into, a couple of units like the scrubber. The scrubber helps you to, scrub off the gas which is entrained with liquid, which is H2, like we see. Of course, you have an element of carbon condensate as well and all of that. So, and that moves through the different compression stages, depending on the compression ratio, as it were, probably taking it from 150 psi all the way to 350, then into like 950. When you are done now, you're about to export, right? You're now taking into some form of trade. The height, the level, the stage at which you can then now be injected into the LNG stream. When I mean LNG line, where you export out. And in this particular unit, a couple of things happen where, the gas stream has to go into the contactor, makes contact with a liquid desiccant called triethylene glycol to help you mop up, strip off H2 out of the gas stream so that it is dry and for it to meet the right specifications and onward and all of that you do, the reboiling system, having a recycle system, all of that happens in this system. And then when you now check the specification, if it makes the right specification before it goes into the LNG line, then you push to export. Now, what I just showed us is simply one of the elements of what you do as a process engineer, which is there are certain things that you must put together in order for you to get to that point. Design, simulating the process. You want to know what happens. Like I mentioned, a couple of things which we speak to when you talk about design basis. So design basis element and all of that. However, you could have all those elements beside, jotted out somewhere. You have done research on the requirements. Perhaps you have the executive having told you that, look, we'll be doing 100 million SCOF. That's what our target is from the subsurface and all of that. You have all of those that you put together and you're about to simulate, you're about to go into all kinds of things and all of that. So there are a couple of engineering tools that are very critical to what we do as process engineers. So a couple of them I want to quickly run through because I know I'll probably running out of time. So now, talking about process design, I have a couple of other softwares you can also use the same objective. Unisim also does something related. Made by Honeywell. They have pipes in typically for flow assurance, checking what happens in your pipe, the different kinds of flow you can have. Whether it's going to be slug flow, multi-phase, and all kinds of things. You want to know whether it's hydrate formation that you have in the pipe flow. All of that you need to check so that you know what you'll be getting at the surface and how you manage your flow with respect to certain, API standard. Maybe there are scientists you're also looking at from other standard you may be adopting. In some industry, Shell DP is also adopted. To also take care of certain designs and all of that. So all of those that I've used in my years of experience, surely be a couple of API codes that you can come across, whether you're doing for PSV, pipe scene, 520, 521, separators, want to design separator, you're looking at API 12G, a couple of things. You want to look at the arrangement of your surface facility. You're probably looking at API 14C. You want to know what is required for a couple of things in terms of integration. You're also looking at the API 14E for flow assurance, what happens in your pipe and all of that. Some other things that are very, very critical to, data management, you're putting numbers, you're tracking and all of that. Some basic fundamentals we've come across as we grow. Even way back in the US, some of us have used some of these materials, Microsoft Excel, MATLAB, and Python for programming. AutoCAD is very, very, very critical. And these are some of the things, the platform that you ever, of course, all of that I have here, you may never get to use some of them, but there are certain ones that you can't run away from, because these are some of the dictates of what you do today as a design engineer, even as architect, other discipline, they use all of these tools, some of these tools. AutoCAD Plan 3D, this is where you'll be doing your P&ID, block flow diagram, all those elements that are required, for the project phases and as the case may be. You also be looking at how to, analyze your process, whether it is safe, as the case may be. Aspen flare system analyzer, you want to see what is the required, threshold, what you are putting somewhere, what kind of PSV are you having there, what kind of release system are you adopting, understanding the basis of your design, understanding what is required, understanding their limitations and all of that. You're going to subject them to, process safety and their risk analysis. Equipment design, yes, HCR, some of us, there are industries that we may never come across heat exchangers, designing. I have worked in a facility that has all of this thing, and this is one of the beautiful things about Aradel. I think I must say this, Aradel has an integrated facility where you have a gas plant that helps to dehydrate gas, from NAG wells. You have a flow station with AG wells, also the gassing, the crude that are around the envelope of maybe around 150 PSI to, 250 in operation. The stabilized crude, if it's fit for the refinery, we also send to the refinery. So, Aradel has all of the industry that you can think of, except for when in fact, we're already going into alternative, power, sources of energy. And that's what Aradel stands for today. So you'll be coming across a whole lot of this equipment, even from the pumps. Just think about it. And so this is one thing I have come to appreciate a lot of things that I've seen in my career when it comes to process design. All that you also be coming across some of this, like I mentioned, to check flow assurance and all of that. Process control as well, MATLAB, same. You'll be doing all of these things. Projects and collaboration. As we begin to talk about project management, because I said earlier, you're not just going to be a discipline engineer as a practitioner who is just looking at, your discipline. You'll be working. I manage projects as well. I have a couple of projects that I've managed in the past and some that I'm doing right now. So obviously, beyond the fact that you are not a discipline in electrical and instrumentation, you are not a discipline in mechanical or facility engineering, but you will still be managing project as a project manager, and you will be interacting with a couple of people. So you must know how to use this MS project, this Primavera, and all of that. Your SharePoint, dealing with the document control, and all kinds of things. Now, we said all these things. You've seen all the elements I've mentioned that is leading to, having practicability, hands-on, what you do, and all of that. But this is what you have on my current screen is where all of these things that you use are used, put together, and delivered. Typically, when you look at engineering design process, what it takes, one thing that is sure is that, our world today is that we're always looking for something to solve, want to solve a problem. And you can't go about solving a problem without first identifying it, doing the research, and let's even just look at it. Do we even have that problem to start with? If you don't have that problem, then why go into it? And there's something about invention, which is challenge, and the need is the dictate of a lot of inventions that you see today, which is you can't go into invention if there is no need for it. I was called into the room 2 weeks back by my way superior. It was an emergency meeting. I said, oh, we have a situation on ground. And I was in the room with a couple of persons, 5, 6 persons. So that we understand as a process engineer, there's a lot that is resting on your shoulder. So I was in the room with the legal experts. I was also in the room with the commercial team. I was also in the room with a couple of persons, and I was only the technical person there. And it was thrown at me while the conversation was going, oh, we have a lot of options here. Yes, that's looking at it from the commercial perspective, and as this conversation was ongoing. One thing about the technical guys is, and this is one of the things I always encourage guys, that don't look at things just on the technical front. You also need some element of business management, knowledge and skills, so that you're not just seeing it as it suits you, but as it is profitable and sustainable for the business. So a couple of questions were thrown at me in terms of the options that were available in terms of gas offtake, and I was like, oh. And they were, oh, we could do this, we could do that, we could do that. And the only business I had there at that moment was telling them that, look, if you have to do this, this will take you about 4 years. If you have to do this, this will take you about 3 years. Oh, this will take you about 2 years. This is the shortest possible that we can do. The low-hanging fruits that you can actually, do, and all of that. These are questions I'm able to give to them, right? But it does also not dictate the immediate decision that will be taken. So you identify the problem. You go and research, you brainstorm in the room, and all of that. So, but when you see this build that I mentioned, yes, the build is not the physical asset you are seeing immediately. So what you are doing was what I showed us earlier, which is you are putting into design and you're just running them, you understand, a small scale fraction. More like a pilot system. You are building it. And when you are done building it, you put it a test. So a couple of things I've done, some of the projects I've done earlier this year is that I was calling to the room, being asked, oh, we're trying to use this other side of the plan to do this. What do you think we can do with it? Okay, yes, let's do this. I put it a test, and I was calling to some form of presentation. Oh, Barry, what do you think is going to happen here? I said, oh, if you go this route, this is what's going to happen. But we can gain some more volume from here. If you do this, we do that. What was important to everyone at that point is that, look, at least you can get value from this asset, which was an add-on and which is going to add, some fund to the revenue of the company. So when you test and you have looked at it, if you are sure, and having done some kind of presentation to a team of other experts. In fact, one interesting thing is that you could build all the things that you have built and they are looking all so nice and looking beautiful. But if the process safety discipline engineer looks at you and say, hello, bro, the angle you are going to doesn't make sense. I mean, you're going to cause us a catastrophic in this place. It's going to cause us a lot of havoc because, yes, as a process engineer, you must be disciplined to understand some of the fundamentals that are required, but there are also certain things that you may never get to understand or see as you put all of these things to work. So when they flag this thing, you think about improving it, right? Then while you're improving it, means that you have identified the problem, and that's why you're improving on it. You go back through the series of, the same cycle, you go around and all of that. So once you test and you see it works, then you present the solution. But once it is justifiable and the management is comfortable with it, then you get their nod, and immediately investment comes in and everyone is good. And at the end of the day, we're all smiling to the bank. Now, what you have here is a typical project engineering phases that you as a discipline engineer, wherever you find yourself, you are going to go through. However, the interesting thing is and why I feel like it is important that I share this with us, because this is actually not project management, but I tell you, whether you like it or not, you just need to understand what I'm about to share with you. Within the next 4 blocks of a slide I'll be sharing with us here. Because as a process engineer, you will go through all the phases, whether you like it or not. From the framing, like I mentioned, I was called into the room and we were just looking at the opportunities, the constraint, the feedstock. Oh, what is the feedstock we have? What is the API of the crude? What's the density? Oh, is it fit for purpose? Can we do this? Oh God, the process engineer is already there, looking at things from the chemistry perspective. Is this possible? And I'll say, let me get back to you. Let me just run some simulation and tell us whether it is fit for purpose and all of that. Oh, and once you can conceptualize and appraise what it is, okay, I think we can do this. You begin to generate some very fundamental things like, just a block flow diagram. You are looking at it. Okay, in this technology, you have to go from here, it has to go from a separator to a dehydrator, to go from here, the water, this and all of that. You're putting all those blocks together, something sketchy, which you are going to, share with the team and all of that. Again, you're also looking at what environment are you operating? Are you looking at a greenfield asset or brownfield? The interesting thing is that greenfield assets are usually the most interesting. They are very lovely. It's a smooth sailing kind of journey, which is just, of course, engineering is not so easy as we think because you are guided by what it is and you meet your itches and all of that. But think about it for a facility that is already built. We're talking about brownfield here. Tie-ins. You see what the constraints are. Are you going to struggle tying in? It's probably an asset that is already productive, that is already producing, and you're already thinking of a whole lot of things. How can we do this to have minimum shutdown? Oh, imagine doing 12,000, 50,000 barrels a day, and you're thinking of a tie-in, and you're looking at a whole lot of stuff. Do I have to shut down this facility for 5 days? That's some revenue erosion. So you'll be looking at the best possible way. I'm sure that a lot of us have heard in cases where you have what they call hot tapping, a live system, which is acceptable in the industry, where you can tie into a live system, while production is on because you don't want to shut down the asset. That's what you call hot tapping. These are some of the things, metrics that you look at. Now, after all of that you have done, the concept selection, you're now looking at the feasibility study, going into some extra kind of works, looking at the economics of what you want to do, put it in simulation, looking at what is available, generates initial heat and material balance. When you take the heat and material balance and show to your other colleagues, some other person may just come to you, I don't think this is something that we can handle. How do we manage it this way? Or I think we need to go through this other route. You may have an heat and material balance. At the end of the day, when you are putting the equipment together, it could cost you as much as $2 million in terms of the equipment you're going to assemble. But there are other possible ways that you could probably do something. For example, in the time past, the way heat exchangers are managed, you are probably using external utility to heat up a system before they can gain it, and you are not maximizing efficiency. You're not running the facility efficiently. But these days, the way some of these things are done is that inherent product that are within the system that are heated up or probably cooled can help you, heat up the system and all of that. And you're able to do certain stuff without bringing external utilities to come and help you heat up the system. So these are some of the things that you look at when it comes to the core works around the space. The feed. Now, the feed is something that is very, very critical. Now, at this point, you have gone beyond something that lies within your organization, because the first two I mentioned are largely things that you could actually discuss with your team, do something that is fundamental. But when it comes to feed, now you're probably now going to engineering design firm, because I operate in a place that we are an operator. We operate and we outsource many of our designs out. And you, as a subject matter expert, your role is to know all of these project stages and what we call stage gates. So the feed that you look at when it comes to feed, which is the front end engineering design, this is where you must start with making sure that you are getting it at least 60 to 90% everything that you want to do. In fact, 90%, just to make sure you are able to get it right at the feed level. So when you're able to put some of this information together, you have the feed package, you have the design report, the model report, and now move to the next stage. Oftentimes at the feed level, when you are done with the feed, the management will look at it and tell you that, look, we don't want to go on with this project. It doesn't look economical. It's not commercial. It doesn't bring value to the business. So we are trying to go away from it. Let's think of something else and all of that. But once you get the management approval, then you now go into what you call the detailed engineering design. And in this phase, you can have what you call the EPIs, which is the engineering, procurement, installation, and commissioning all together. So in this phase, you are going to get very detailed, which is the number of hours that are required, things that are required to finish the contract, to finish the project and all that. Because the detailed engineering design will largely speak to all of the design component, every element that is needed to finish the project from A to Z. And this is what will be evaluated in terms of the cost, that is required. What I'm saying is that the budget that is required in terms of expenditure, to carry out this project. Then when you are done with the DED and the building of, everything, the system is already on ground, you built the nice thing that you're looking at and all of that. As a process engineer, again, you come to this place. You are now looking at your crossing the T's and dotting the I's and looking at the things. Or what are the design bases? Or did they meet the specification? What were the things I gave them when it was being designed? Let's look at it, whether those specifications were met. Let's look at it, whether the right things were done. At the pre-commissioning stage, which is static, the plant is still there, done. So you are now looking at, you have what you call the punch list item. You are looking at what is important, that is not, practically everything, element of the deliverables, you are closing them out. Are the system properly tagged, mapped, so that when the operators are ready to operate it, they know what goes to where, what valve to open, what leads to where, and all of that. You must make sure that that system is ready for purpose and ready to operate. Then we'll go to commissioning. Again, commissioning. Now, in this case, you are now coming with your, the simulation I showed us earlier has a two-part of it, which is you have the static, which is the steady state condition. You also have the dynamic situation. So the dynamic situation is what we know some of us have come across. I'm sure some of us can relate to what you call the ideal gas and the real gas, So the ideal gas is, okay, that is what it should be. All things be equal. But we all know that, look, all of these things are subject to environmental conditions. The weather could change, the pressure could change, the fuel characteristics could change. So you need to look at all of these elements that you have for your commissioning to be sure that the dynamics are matching what you have predicted, right? So once you are looking at all of these things, you are following the procedures that that are critical to the commissioning of the plant, how you should start it, what are the necessary elements that are there that should be up, when you are commissioning this plant. Once you are satisfied with all of that, you continue to run. There are cases where you have to shut down. You evaluate again, see what is not right, fix it, start up again, and all of that. Then you continue to do what you call performance test to be guaranteed that, look, everything is up to spec. Now, performance test and handover. While you are doing all of those commissioning, the operators are waiting for you. The management is looking at, what is to come. They're already getting feelers that the facility is already being commissioned. Train 2 is, the distillation tower is running. The pumps are responding the way they should. The heaters are up. The boilers are working perfectly well. No leaks anywhere. The tanks are receiving, product, and everybody is waiting for what the specification of the end product is going to be, which is usually what's, elates the mind of the executive to say, we planned it and we are getting this value from this asset. And immediately the product comes out from the tank, and the laboratory engineer has put it to test and telling them, look, the specification coming out from this asset is wonderful. And everybody starts to celebrate. And the process engineer is also giving reports back. So, you have all the necessary, certificates, tests, everything that is required. You are not also messing up the environment out of making sure that you have a quality specification and all of that. Everything is just on point, that you are maximizing opportunity. You are optimizing adequately, So when you are able to do this, everybody smile, and we begin to smile to the bank, and you are ready to hand over to the operators. Now, When you now hand over to the operator, your job is still on. You still haven't finished what you're doing as a process engineer. Because after you're done with the entire design phase, commissioning phase, the next 6 months, 1 year, you are still getting reports from the operators, trending the performance of this unit to see what is happening. It is even important that, look, when a facility starts to run, you must continue to trend from day one to see how it is doing. If you are doing well from day one and you have locked it in somewhere and you are trending it every day, the day you see your heater not doing well, or you see a particular exchanger not doing well, you're able to trend to say, oh, this is where my problem lies. Let's bring out this plant and do some sort of maintenance, right? Or probably have heat exchanger fouling, and this is why you're having the heat exchanger not working efficiently. The heat exchange is poor, and the outlet temperature out of the heat exchanger doesn't make sense. And I have a young colleague that came, we were discussing something similar, and it was actually that direction we are looking at. Something's probably wrong somewhere. Let's optimize, let's inspect, let's investigate. Once we are able to fix it, you come back on stream and you are getting value for your assets. That's all that when it comes to being practical about having hands-on and all of that. But let's get into why your role as a process engineer, why the process engineering as a discipline is very relevant in our industry. Historical context. The part of process engineering itself emerged during the 19th century. A couple of things were happening. The way it is was something that was very small scale, right? Until Industrial Revolution happened, which laid the foundation for mechanization. So when we say mechanization, so we are talking about going beyond what we see as very basic, and we're trying to make sure that we speedily get more productive in terms of the scalability, making sure that we are able to produce for more than 10, 20 places that we are now looking at in their thousands and all of that. But it was funny that when these things were happening, the mechanical industry, which are the mechanical guys, most of these things were premised on their actions, which is, so somebody could look at, oh, I need this volume of liquid, just to feed this community, water. I'm talking about water now. Let's say you want to serve this community. It didn't matter, what they feel is adequate to give to that community. Somebody can just look at it and say, okay, just go and put 6 inches pipe there. It should be adequate. But at the end of the day, see some sort of struggle, and somebody is wondering, why is this water not adequate over there? Why is this liquid not getting to that place? A couple of things were happening across the entire industry where process engineering was not taken into cognizance as while it is important. Of course, the different arms of our science world, which is the chemistry and physics, were operating independently. So, and then the term chemical engineering now, was now formalized around 1888 to bring chemistry and physics and the mechanical design into all of that. So, and that was how it came about, chemical engineering. I'm sure that some of us, we must have gone through the aspect of when we talk about what do we call it, process engineering. I think there's this topic that I know that I think process engineering or something like, where you have to know about the batch, the CSTR, the PBR, the PFR, knowing all of that is required when it comes to chemical engineering, knowing the kind of process you need to pick. Is it going to be a batch operation? Is it going to be a continuous process and all of that? All of these things dictate how you build a system that at the end of the day, this system becomes profitable. Because it doesn't make sense at the end of the day, simply because you just want to have a pipe somewhere and feed the community. You're building almost 24 inches pipe, whereas 6 inches would have done it. And for 24 inches pipe, you are probably spending as much as $2 million. And maybe the next one that will have done the job is just probably like $500,000. You have the eroded value of almost $1.5 million, which doesn't make sense. So by the mid-20s, as a chemical engineer, it evolved and design, optimization, and control of plants, and a couple of things were happening. And let me say this, across the entire industries, not necessarily oil and gas, it may be a pharmaceutical company, it may just anywhere where they produce, there is an end product to what you put in your mouth or what you use on a daily basis. The chemistry you are putting together to form these things, when you put a formula together, something that transforms, some kind of chemical reaction, and you are getting value, you are getting a product at the end of the day, you must be able to put it into some form of end product that is valuable and is not just bogus, and that is precise, optimally produced, so that you are getting value for it. So why process engineering became necessary, like I mentioned, you understand, all of these different disciplines that were working differently, making, the industry get value from what they are doing and all of that. So process engineering brought all of that together, in terms of integrating the design, quantifying transformation. So like I mentioned, the tiny dynamics effect, a whole lot of things happen when it comes to this industry as a process engineer. You have so much on your shoulder. And even when you are done, they are still asking for more. How can we get more from this place? You begin to optimize, and looking at it. You're also looking at how do you scale up. Just quite a number of things happen as a process engineer that you'll be looking at. This was why it was necessary that in this industry, process engineering became so important to every other discipline that wants to exist in this our industry. The process engineer is the dictator of what it is. They guide these other elements. So still talking about what it is, evolution into modern engineering practice, the core logics of the industry systems, oil and gas, energy transition, manufacturing, safety and regulation, and all of that. Theoretical relevance of process engineering, a couple of things that you'll be seeing. Let me quickly run through them. I have about 20 of them. Facility design and optimization. This is what you'll be doing as process engineer every time. Production maximization. You want to get more value, you want to maximize, effort. Flow assurance. Can this fluid move through this medium and to don't get stuck? It's going from point A to point B. You should be able to evaluate and say, I'll deliver so X amount without wax, without hydrate formation, and all of that. Can you do that? Process safety risk. You must carry out ASOP. You must carry down hazard, which is hazard identification. You must know all those things. Environmental stewardship. Do you want to flare into your system? It doesn't just make sense. And this is one very beautiful thing that Aratel has done over time. If some of you may, I don't know, you may want to have a walk through to Aratel someday. If you get the opportunity to come visit our integrated facility, you're going to see that we are compressing our gas. We're not flaring. We are not fouling our environment. We are a very responsible business. Energy efficiency, like I mentioned, a couple of things you want to do. You don't want to waste energy. Some equipment are not necessary when you can use, certain things, just to make sure that your operating cost is not so high. Process simulation is also what you'll be doing a lot. We've gone beyond of course, some of us are still the old dogs where you pick your pen, you still want to validate some things by doing them with your hands and all of that. Sometimes when I talk to some engineers, something to just make them, practicalize what they do, I tell them, okay, well, do you still remember what continuity flow equation is? Okay, you want to know the flow rate. Okay, what do you have? Do you have these variables? Do you have velocity? If you have velocity, okay, what's the pipe size? Okay, is this diameter? Okay, go and give me the flow rate. And you do your Q, equals to VA and all of that. So we still do some of those things, some of them. So beyond the process simulation, we still do some of this thing by doing an hands-on. You have commissioning and the startup supports, all of that. Production chemistry integration, metering and allocation. You want to get value for what you are sending out so that you're not losing money. Process troubleshooting. This will always happen. This will always happen. The operations team will always call you. Bureau, I don't know, this pump is not injecting well. What's happening? You want to see it, but it's still doing the same flow velocity. So what's happening downstream? Let's go and check. oh, the pressure here is elevated, so there is a back pressure. There's some kind of back pressure here, and when you have a back pressure, so that means that there's a resistance somewhere, so you're not having adequate flow. All kinds of things you'll be seeing. Troubleshooting is what you live with throughout the life of every plant. Design basis for brownfield modification. I said this earlier. A brownfield is, in fact, is one of the most complex that you can work on, because the challenge will come. The well dynamics will change, characteristics will change over time, and you want to try and do what is right and make sure that it works fine. Pressure relief system, you want to make sure that you are not pressurized unnecessarily. Produce water treatment. You also don't want to foul the system by throwing out water that are not properly treated and all of that. Gas processing and conditioning. Integration of renewables, regulatory and standards and compliance. You'll be dealing with a lot of regulators, stakeholders, all kinds of people you'll be meeting during your project phases. Economic and evaluation. Does it worth it? The investment, CapEx, OpEx, what are you looking at? Are you estimating and all of that? What's the cost benefit of what you are doing? Interface between discipline. I said this. You'll be dealing with a lot of persons. Everyone will be asking you questions. What's the basis for this? Because nobody can give you what valve will manage the system. The E&I guy cannot give you the right valve if you don't tell him the volume you are looking at. As a matter of fact, you will size the valve and tell the electrical and instrument persons what valve size in terms of the CV, that will be purchased and all of that. Interface between life cycle and asset management, all of that will be managing. Conclusion. The role of the process engineering, if you look at it as, it is, I've spoken to a couple of things you'll be doing throughout your career. It's not just a branch of engineering. It's a deep consciousness of the industry. Everyone is looking up to you. You must make sure you get it right from the start. You must be able to guide each discipline by making sure that all of the elements that are necessary are used, and every party is guided by what is required to execute their different side of the project. So it must be reliable. It must be profitable. It must serve the purpose for the planet. We don't want to foul our planet. As we talk about the global warming as we speak right now, I'm sure some of us have come across a couple of things talking about how to manage our CO2 and all of that. A couple of technology are out there, which are still, being tested to see how we can recover all of that so that we can maximize what we produce, right? And also making sure that we do not foul the environment. Our world runs around these processes, and they should be run safely. Okay, and knowing that without process engineering, our world can never be safe. It's just a fact. Can never ever be safe. We have to be very mindful of this. And as a process engineer, you must understand that you are the custodian of system integrity. Thank you. Elias.
Thank you very much. Heard? Yes.
So I will
Yes, I hope everybody heard Dr. Barrow. Yes, if anyone has a question, please don't hesitate. Write it, or you can raise your hand and I could call you out. And if you have any inquiries or anything, this session will last for only 10 minutes because we are out of time. So we'll make it like it should last only 10 minutes because other things should still go on. So if you have any questions, please don't hesitate. This is it. We all been waiting for this moment. We all want to hear. A lot of young generations are here. Everybody wanted to know how the processing is. How do we do it? So engineer Barry is here. Let's go on. Don't be shy. Just ask questions. If you feel like you can't speak it, you can just write it, and I could read it for you, and you could hear it. So, oh yes, Abbas, please. You're welcome.
Okay. Good evening. Please confirm you can hear me clearly.
Yes,
Yes, we
Abbas, I
can
can
hear
hear
you,
you.
Abbas.
Okay. Thank you so much for sharing. It was a well facilitated session and then with so many insights. Although for me, one of the things I was hoping to get clarity on from the discussion was perhaps some sort of an overview guide for process engineering enthusiasts on competency development. So for instance, for early career stage, say between 0 to 7, 10 years, these are the things that should be your core focus within this stage. And then maybe moving on to the middle career stage, maybe 10 to 15, 20 years, and then this should be your focus. And then maybe later on, I don't know if you can just provide some quick insights
Yes.
into this as well from your experience and knowledge.
Yes,
Thank you so much.
thank you, Abbas. That was a wonderful one. So typically, and that makes sense. But of course, we know that we have a very short time for this lecture, and I was just trying to see what I can quickly put out there. I would say from my background, which I usually tell young engineers, depending on the industry you find yourself, which we must first understand. So if you find yourself in an engineering design firm, so what it means is that you may never get to even see some facilities, when I mean the live facility and all of that. So one thing you must understand in order for you to build yourself towards these stages of your career is that you must start with the fundamentals. So the fundamentals are very, very basic, but of course, whether you like it or not, from day one, the company you're probably working with wants you to hit the ground running, but not so bad, depending on this discipline that. Depending on your background. So for us, I did chemical petrochemical engineering, of course, so I'm familiar with a whole lot of stuff when it comes to the chemistry, transport phenomenon, field mechanics, and of course, I know a lot of us during our university days did field mechanics, thermodynamics, and all that. Essentially, you may need to dust your fundamentals up again because you come across them again. Of course, life has been so easy trying to use tools that we have today in terms of what I just showed us now, process simulation, knowing to do out of that, knowing how to do all of those things. But you must learn the fundamentals. And there is something that is very critical to all of this. As a process engineer, make sure that you help yourself and guide yourself with the fundamentals, what we call the codes for designs. So if you find yourself in any organization, day one as a process engineer, pick up all the API codes as SPE. Make sure you find all of that. Find Shell DP. Once you have all of those things, what you will notice is that as you begin to apply this in your career, you'll begin to see all of those fundamentals that I've mentioned, where they are applicable. There are assigned practical steps you'll also be seeing where you'll be seeing yourself doing hands-on calculation while you are working on that. API 12G, when you are designing a separator, you actually see where you'll be doing a lot of hands-on, work there. So pick what you call API codes. If you want to get yourself familiar with ASME, to pick that to learn all those design for the guidelines. Those will help you to know how to, and once you know that, you're able to speak to a whole lot of stuff, especially when there are design firms that are dealing with you, you can actually query what they are doing. Once you know some of these fundamentals, for example, in a pipe flow, you probably need to make sure that you shouldn't go below 3 feet per second and 15 feet per second, and somebody is bringing something to you and is way above that. You can query it. And if it looks like this person is telling you it is not possible, then you have to go back to your fundamentals, like I mentioned. Simulation is also something that you need to try. It helps you, right? But if you find yourself in the upstream sector day one, if you have the opportunity to work with the operations team, which is seeing the live plant, you can see how it works. It speeds up your knowledge in process design. Thank you.
Okay, thank you very much. I hope, Abbas, you understand. what Engineer Bear said. Let's go on with the questions because we are out of time. So somebody asked, does Aspen HYSYS also do costing?
Yes, but then I will ask us. It does costing, but then you have to also be very careful. And reason being is because even after simulating, there are quite a number of things. So it's going to be estimates, right? A couple of things also, are dynamic when it comes to costing. So if you want to do costing, it could be premised on, scratch information, something just to have a quick information as case may be. But then when you want to do costing, please go through the proper route by making sure that you engage with subject matter experts. In every organization that wants to be profitable and that wants to do proper market survey, making sure that they have the right numbers, you must have a cost engineer within your system, and also make sure that you have what you call a sort of repository for all kinds of projects and their costs and all of that. That's the proper way to go. Don't just rely on the simulating units.
Okay, thank you very much for answering that question. I hope the person who asked the question understands what the answer to the question. Okay, let's go on with the question. Somebody asked, how can young profession learn those tools to add more skills? That is, OLGAT, while they are licensed, while they are very licensed and expensive.
Well,
like how can we like make like
that's the dilemma of our industry. That's the sad reality. But the truth is this: any organization that wants to get value from its workforce must invest in order for you to use it. I think I'm also aware that in some cases there are student versions for some of these things. I may be wrong, but I think that's the case, right? But if you work in any organization, you should be able to have some of these things to use.
Okay. Is it possible?
Hello,
Can
I come in?
Yes, Sylvester. Yes,
Just
please.
to
Yes.
add to Engineer Bello is saying, for the question
We can't
that
hear you properly.
can you
Please.
hear me?
Yes.
Can you hear me?
Yes, we can hear you.
Okay. Yeah, I said what happens is for those two proprietary tools, if the person that asked the question look very well,
Now it's clear. Now we can hear you a little bit. Yeah.
Now you get crack factions. You have people that have a lot of crack factions that you can learn, because not until you get into the industry, you will not have access to those tools. But before you come in, and if you want to be competent in some of those stuffs, you just need to look around and get some of those crap. I am an ROE reservoir engineer, but by streets, I also double as process. As we speak next week, I'm commissioning a 10 kbd process plant, EPF, or let's say a full-blown station, bringing in rig again to develop for that, and a refinery that is 30,000, but 10 to start with. But I'm not a process person, but by virtue of using all of these roadside crack ICs, PDMS, and the likes of
Sylvester, is it Sylvester that is speaking?
Yes.
Can I quickly say something here? So let's be guided. Crack version for our industry is not encouraged. We need to know this. And it's when you say crack version, obviously you know what it is. Which is you are going overboard and you are doing what is seen as illegal, and nobody wants to be found in that light. So again, like I said, there are a couple of software you come across that are student version, okay, that you may learn from, that you can use. Any institute that could actually train you if you put in one or two investment in terms of and what it costs to do those training. Their platform to probably do one or two things. So let's get that. Okay, Elias, can we take this? Can we take the next question?
Yes, please. Somebody asked, is it possible to run 100% refining operations without flaring?
No. So you also don't want to do something. I mean, of course, you want what you call technical flaring. You want to see that you have what you call a pilot, flaring, which is, you have the system. Don't forget that you have a closed system, and you want to be sure that you are running safely. So you still have a tip of that little smoke, that fire that you have there, but you must be extremely very, very marginal, very, very, very marginal, so that you see what is happening in your system.
Okay,
And when I
so
mean
let's
marginal,
round up the
you have to
question.
do 99.9.9.
Okay, let's round up the question with one last question. What's the difference in application of Prosper and Eclipse software on simulation?
Okay, I have a couple of persons that I've been in a multidiscipline team. So we have a team called WRFM, which is Wells Reservoir and Facility Management. So I manage the facility management side of things. So and I haven't heard about Eclipse and the other one that was mentioned. They are largely used for I think reservoir management, if I'm not mistaken, and the subsurface works and project and all that. So what is largely used for surface, you have subsurface and you have surface. So what is largely used for surface is you have a couple of that I mentioned. If you move back to what we have, okay. So somebody just said reservoir management. Thank you, Amre. So like I said, so for surface management, you have pipe sim. You have there are new that are out there that are there now. A lot that are out there. Unisim. I mean, that's much that I know that I'm familiar with, that I've come across.
Okay, thank you very much, Dr. Barrow. I think that was a very, very good session right there, question and answering. And if you have any more questions, we will find a way to write a link whereby you can write all your questions and we'll direct it to Engineer Barrow. So let's go on with this. So the next part is I would like to welcome John Adekun from YPSP presenting the certificate to Dr. Barrow. John, can you hear me?
Yes, I can hear you. Am I audible? Confirm you can hear me.
Thank you very much, John.
Hear loud.
Yes, we can hear you, John. Yes.
Okay. So on behalf of SPE Warri Section 104, Engineer Barrow Adepitan, we appreciate this enlightening lecture and a wonderful presentation. So on behalf of SPE Warri Section 104, we are presenting certificate of appreciation and recognition for facilitating our November lecture on process engineering for sustainable upstream and midstream operation, the dynamics and relevance. Once again, we have learned a lot. We've gained more insights about how the process engineering works in the oil and gas industry, and we believe we are inspired to do better and to contribute our own quota to in the oil and gas industry. Once again, on behalf of SPE Warri Section 104, thank you so much, sir. We are presenting this certificate. Thank you. Ida, over to you.
Thank you, John.
Okay, that was the part whereby we give the certificate to Barrow, to Engineer Barrow. I hope this was good for every side. Thank you so much, Dr. Barrow, from across the region. As from Tanzanian section, we are very happy to be part of this section. We're very happy to receive the processing. A lot of things are happening in our country, but processing is one of the biggest things because a part of our country is using oil for a lot of things. So processing is a really good thing, and it will be a really good new technology and all that stuff. So thank you very much, Dr. Barrow. So we'll go on with the
Thank
next
you,
part.
Elias.
So
Thank
this
you.
part is whereby we will, you're welcome, Dr. Barrow. So this part where we'll be taking the photograph session. So I would like everyone who is able to turn on the cameras so we will be able to take a picture. I hope you guys can hear me, right? So if you can, please, we'd like to take this and put it in on our memories. Yes, please. More. I need to see more people so we can take the picture. Thank you. Thank you. I keep seeing people. Yes, you're all welcome. Please, you're all welcome. Okay. So everybody be on your best face because we are gonna take a picture. Yes. So count to 3. I'll count to 3. Okay. I'm taking a picture. Okay, thank you. Thank you very much. Thank you very much, guys, for the cooperation. That was good. That was very wonderful. Thank you so much. So without further ado, let's keep going on our slides. I think we're in the end of the slide. I would like to welcome now Dawoodi for us to give us the awareness or upcoming events if anybody's interested. So Dawoodi, can you hear me?
Yes, I can hear you. In a very good place. So actually,
Your voice, you're cutting out. I think there is a little bit noise on your side. Could you please move in a, in a
okay.
side which is a little bit,
Can you hear me? Can you hear me?
Yeah.
Okay. What?
Yes, Dawoodi, you can keep going, please. We're like running out of time.
Okay, thank you so much for this opportunity once again. Good evening once again, everyone. Thank you, our moderator. Thank you, the host and our facilitator for a wonderful and insightful lecture. So just a quick one to keep on bringing up the SPE awareness and upcoming events. So, okay, so our Society of Petroleum Engineers has been growing really well and really fast. And as we know that the SPE International, under this society, we've got different sections, and under these sections, we've got students chapters from different universities. So it's really good to become an SPE member. So as we know that at first SPE was known as the Society of Petroleum Engineers, accommodating only petroleum engineers. But it's been growing, it's been accommodating even engineers from other fields because we have these engineers also working into petroleum projects. So we have all sorts of engineers under the SPE. So it's a really good platform for engineers to grow and connect. So within SPE, you can get, these are some of the benefits that you can get from the SPE. You can get first-hand internships on career information. because the SPE has been providing in its platform. You can access different opportunities for internships and career opportunities. Also, you can access mentorship programs from industry leaders and experts. Also, through SPE, you can get a variety of scholarships and trainings. But also through SPE, you can access to the vast technical and professional resources, for example, library and knowledge base. But also, as I said before, through SPE, you can network. You can network with different industry leaders and professionals, both from your local section or student chapters, and international from other sections and platforms as well. For example, even in our webinar, we've been able to, as Tanzania section, we've been able to connect with Warri section and have this wonderful webinar. So there are a lot of benefits that you can actually get from the SPE. We have different competitions to nurture, to keep on nurturing our knowledge in petroleum and engineering, all engineering fields at large. We have the petrol balls for students, and even in our region, the Africa region, we have seen different competitions within universities and also at a regional level. So they really help in nurturing our knowledge in petroleum engineering and all other petroleum fields. So if you are here, you're in this meeting, in this webinar, and you are not yet a member, you are not late. This is a good opportunity for you. So you can see the QR code right there. You can scan it. You can scan it. You can join. If you scan this QR code, you can access the SPE platform. So, but if you want to use the website, you can also access SPE International through spe.org. spe.org. You can join as a member, but also you can create your professional profile there. You can access a lot of information and all the benefits that I've mentioned. But also, anytime your membership your membership ends, you can get a chance to renew. And also for students in our universities, you can be a student member, but also when you are done with your studies, you can get a chance to be the professional member. You just have to visit the website and renew your membership and keep enjoying all the benefits within the SPE. We are SPE Solutions, People, Energy. Thank you so much and welcome to the SPE.
Thank you very much, Daudi. Thank you very much. I hope everybody understood. You don't have to be a member this stage. You don't have to be a person associated with oil and gas. You could just be there for inquiries. Everybody's there. You could ask about it. We are all interested. We are very welcoming. We have very good hospitality. You can ask anybody about it who is related to it. And if you want to be a member today, it's going to be good for you. It's going to be very beneficial. I promise you, you won't lose any time. Connections, every single thing. We are here from across the region, from Tanzania, from Warri, from all over the region, even above. This is all because of SPE. So I think I encourage everybody, I encourage everybody to join SPE. So without further ado, I would like to conclude to this session. I would like to welcome Patrick Akwagu for closing remarks and vote of thanks. Patrick, can you hear me? Is Patrick here?
I can hear you. Hello, can you hear me?
Yes, now I can hear you. We can hear you now. Thank you, Patrick. Please, you're welcome.
All right, thank you very much. Good evening, everyone. And thank you very much for making our time to be here today. And especially, I would like to appreciate every YPs, the YP from Warri section, YP from Tanzania section as well. I would also want to especially appreciate Dr. Sylvester Okuti for his excellent opening remark. And lastly, Engineer Beru for his insightful lecture on process engineering. I believe we've all understood the intricacies of what process engineering entails and how the role cannot be overemphasized. So thank you so much, Engineer Berry, once again. And we look forward to more collaborations, and we hope that whenever we call upon Engineer Berry, will definitely answer our call. So thank you so much, everyone, once again. But before we conclude, we would have to retake the group photograph. So please, if everyone can just turn on their cameras so we could retake the photographs again. Yeah, confirm you are with me. All right, so we'll be taking the group photograph now. Okay. All right. Okay, so over to you, Hilat.
Okay. Thank you. Thank you, everybody, for that. Everything was said by Patrick, everything was said by Dr. Barrow, everything was said by everybody who was hosting this. I would like you to thank you all for your time. I know everybody was busy, some people are in the bus, some people are everywhere. So thank you very much for joining us. And if you have any further questions, we're available in SPE networking, in SPE. Please follow, if you're from Tanzania, please follow your YP who is here. Please follow me if you have any questions, if you have any concerns, if you have any comments. If you're from Warri sections, there is Patrick, there is Paul. Please ask anybody. Please don't be shy. Thank you very much for having us. Thank you very much for your time. And good night to everyone who is here.